So this is a short discussion of the conceptual meaning of Ohm's law. And for me, when I think about a conceptual meaning for some idea in physics, usually to me it means some sort of physical interpretation, that I have a physical picture of what's happening. So that's what I'm going to try and offer for Ohm's law. So Ohm's law is the equation delta V equals IR. It says that the voltage drop across some resistor or resistor type element, something like a light bulb, that the voltage drop across the resistor is equal to the current flowing through the resistor times the resistance of that resistor. So let's give each of these terms a little more meaning. So delta V is related to the energy that the electrons transfer to the resistor. So as the electron moves through the resistor, the electrons lose some energy. That energy is transferred to the resistor, and how much energy gets transferred is related to delta V. The current is related to the speed of the electrons as they move through the resistor. So there are many electrons traveling through the resistor. They have some average speed, and that average speed is related to the value of the current. And the resistance is a measure of how difficult it is for electrons to move through this material. So depending on the size and the material of the resistor, it will have some resistance, and the bigger that resistance is, the more difficult it is for electrons to travel through that material. So what Ohm's law basically says is that the energy that the electrons transfer to the resistor depends on how fast the electrons are moving, that's the current, as well as how difficult the resistor is to move through, that's the resistance. So delta V, the energy that the electrons lose, is related to I, a measure of how fast they're moving, times R, a measure of how difficult it is to get through this resistor. Now you might be wondering, why does the energy that the electron loses depend on its speed? It seems very natural that it should depend on how difficult it is to travel through the resistor, but why exactly does it depend on the speed of the electron? Well, what's happening is as the electron travels through the resistor, it's going to bump off of some of the atoms in the resistor. So the electron doesn't quite go in a straight line, it sort of bounces back and forth between the different atoms as it moves through. And as this happens, as the electron bounces into the atoms, each time it hits one of the atoms in the resistor, that atom is going to start to vibrate some. So as the electron moves through, it bounces into things, and each time it bumps into one of these atoms, the electron loses some energy, and the atom starts to vibrate some. And in this picture, it seems pretty natural that the faster the electron's moving, the more it's going to make that atom in the resistor start to vibrate. The more the atom vibrates, the more energy the atom must have gotten, and so the faster the electron is moving, the more energy it's going to transfer to these atoms in these collisions. It's essentially going to collide with more force and transfer more energy. That's why it depends on the speed of the electrons.